Okay, so this section is going to start our trigonometric section, and we're going to look at special triangles. And our two special triangles is a 45, 45, 90 triangle, which if you can process right, when I have two same angles, I have two of the same sides. It's my isosceles triangle. That means that two of the legs are going to be the same, and the hypotenuse is going to be longer. Now, this whole section is on patterning, so we're going to ask that you follow it, and then we're going to reteach you a little bit of radical simplification to get through it. So, for 45, 45, 90, if we call each leg x here, okay, the hypotenuse is root 2 longer, okay, a factor of root 2. So we'll do an example here to explain that, but I think that makes sense to you a little because if x was 1, do you know from Pythagorean theorem that 1 squared plus 1 squared would be 2, and then I would take the square root, so the hypotenuse would be root 2 if both of these were 1. So just as a little pattern here, if I know a leg is x, to find the hypotenuse, I multiply by root 2. Now, what we're going to discover is if I have to go backwards and I know the hypotenuse, I have to divide by root 2. Okay, so that might be a little confusing to start, but let's see if we can apply it down here. For number 1, they gave me a leg which is 8. That makes this x pretty simple. It's just 8. It's the same thing. Now, how do I wrap around to here? The hypotenuse is longer. How much longer? It's multiplied by root 2, which is 1.4. So that's how you would put that in your calculator if you need a decimal, but it would be a factor of root 2 longer, and that would just be a shortcut to get the exact answer. Let's do number 2, see if you can pick up on it. They gave me a leg here, 25. That's easy. That makes y 25. Okay, that's the easy one. How do you get around to the hypotenuse? It is longer. How much longer? It's a factor of root 2 longer. So 25 root 2 is how you write it. Now, normally we don't put that little times in there. It's assumed, but I just want to explain to you when we do it. Now, for number 3, it gets a little trickier here when they give me the hypotenuse. How do I wrap around here to one of these? Well, I have to divide by root 2. So for both of these, I'm going to accept this as an answer, 19 divided by root 2, and this would be 19 divided by root 2. There's a way to rationalize the denominator that you'll learn. So if you see answers like 19 root 2 over 2, that's the same answer, but that's what I would like to get to. So again, the legs are the same. The hypotenuse is root 2 longer. Now, let's look at a 30, 60, 90 triangle. This one's not quite as simple because I don't have any legs that are the same. All right. Now, what we are going to say here, Mr. Nye is going to use the term you run to the short side. Now, which one's the short side? It's the one opposite 30. Okay. If I have that, going from the short side is not too bad. The pattern here is the hypotenuse is longer. How much longer? It's twice as long. The long side, which is opposite the 60, is longer. How much longer? It's longer by a factor of root 3. Okay. So again, if I know the short side, to get the longer side, I multiply by root 3, okay, multiply by root 3, and to get the hypotenuse, I double it. Now, the struggle comes in a little bit when we undo those, okay? But let's do a couple examples here and see if we can see. So for the first one here, this one's nice for number 4, because what it does is it gives me the short side, because it's opposite 30. So, how do I get to the hypotenuse? It's double, so it's going to be 10, right, times 2 going this way. How do you get this way? It's longer by a factor of root 3. So a simple way to write the answer is 5 root 3 in radical form. Now, why is that better? Because I don't have to round it. All right, let's see if we can do 5. 5, again, gave you the short side, so that's a winner. So how do I go to the long side? The long side is times 2. So that would make this 28. How do you go to the long side? It's a factor of root 3 longer, so it's going to be 14 root 3. And again, it's really 14 times root 3, and that's what you would get. Now, it's a little worse down here when they give you different portions of this. So let's look at number 6. They gave you the hypotenuse. It's actually not too bad normally, but what I'm going to use the term is you want to run to the short side, because the short side is where I want to go first. So I'm going to run here. If I go there, I know that I multiply by 2 to go from the short side to the hypotenuse, so here then I'm going to divide by 2 to go back. So that's not too bad, 16. Now once I get 16, I can wrap around here and get the long side using the same process. It is root 3 longer, so I'm going to get 16 root 3. Okay, so hopefully that kind of makes sense. All right, so I'm just going to look at 8 and 9 here then quick and see if we get these. So for number 8, they gave you the long side. So this right here is a little bit not as great, all right, for this one. But again, I want you to go to the short side. So to go to the short side, I'm going to divide by root 3 this time. So I'm going to get something like, oh, let me put it in a y because I mixed them up. Okay, so if that's y, it's going to be root 20 divided by root 3. Okay, and that's going to be, okay, not root 20. What am I doing? Sorry, let me try again. It's going to be 20 divided by root 3. Okay, and I'm going to accept that as an answer. Now, one thing I might ask that you do, once I know that this is 20 divided by root 3, in going to the long side, I'm going to multiply by 2. I would like you to know if you multiply this by 2, that you can multiply the numerator. I think I'd prefer this to be 40 over root 3. I don't need you to rationalize the denominator. That's where I'd like you to be able to get. Now let's look at number 9. Number 9 might not look like a good start, but it is because they incorporated the root 3 to start. That's going to make things a little better. And what do? This is the long side because it's opposite 60. I'm going to run to the short side. So what are you going to do? You're going to divide by root 3. So that's kind of nice. That gives me x is 9, a nice whole number. And then what can I do? I can go from the short side to the hypotenuse. Do you remember what I do? Multiply that by 2 to get the shortcut. It would be 18. Okay? So these are patterns for an isosceles right triangle, okay, which is a 45, 45, 90. There's a factor of root 2 involved there. Also a 30, 60, 90 triangle that incorporates a double, if you want, times 2 and times root 3. So let's go down here and do a couple of these and see. All right, let's look at number 10. Okay, so let's see if we can review. Number 10, not ideal, because they gave me the hypotenuse. So do you remember what I do? It's a 45. Therefore, right, x and y are going to be the same. And what's it going to be? This one's going to be 28 divided by root 2, because I got to go backwards. And this is going to be 28 divided by root 2. Okay? All right, let's look at number 11, just to review. Number 11, they give me the hypotenuse of a 30, 60, 90 triangle. Where do I go first? If you remember, you're going to hear me say you run to the short side. Do you remember what I do when I run to the short side? I'm going to divide by 2. Okay, so that's going to give me 8. And then I'm ready to apply the rule. So how do I do when I come over here? It is root 3 longer. Okay, hopefully that makes sense. All right, let's look at number 12. Number 12, a little easier. Why? Because it's a 45, 45, 90. I have 4. That makes x simple. It is 4. How much longer is the hypotenuse? Again, I just need you to start the process that a 45 incorporates a root 2. It is 4 times root 2 longer. Okay, so if I go down here, let's do number 14 here quick, and then we'll stop there for the video. So again, they gave you the long side. This is kind of a winner. If you have 15 root 3 for the long side, what are you going to do? You're going to run to the short side. How do I get there? I'm going to divide by root 3. So what makes nice about that? That's 15, a nice even number. And then how do I go from the short side to the hypotenuse? I double it, giving me 30. Okay. So these are shortcuts that we need you just to start to process and know the pattern to do them. And throughout the next couple sections, we're going to learn something called trigonometry, which is going to allow us to solve triangles that have different angles other than 45, 45, 90, and 30, 60, 90. That's where we're going to start. Now, one other just note quick, we are going to limit your homework to do 1 to 10 on the assignment, and I'll go over that. But we're not going to do the compound shapes. So, all right.